Hello everyone, myself Purani. I am a research scholar at Gujarat Technological University and presently working as a lecturer at Sri KJ Polytechnic Bharuch. My supervisor is Professor Dr. Indrajit Trivedi. He is presently head of the Power Electronics Department, Vishwakarma Government Engineering College, Chandkheda. The presentation is for the selected paper with paper ID 632. The title is Estimation of Solar Energy, Inverter Configuration and Issues with the Penetration and Distribution Systems. I hereby welcome you all for the proceedings of International Conference on Electrical, Computer and Energy Technologies ICECET, which will be held on 9 to 10 December 2021, Cape Town, South Africa. This is the flow of the presentation. We'll start with the introduction, then generation estimation. The basic information regarding the estimation software we have used is PVShift, inverter configuration, issues with the penetration, conclusion, and the feature scope, and some references which we have used. First of all, with the introduction, Sun is undoubtedly the largest source of energy of this universe that we all know. For a very long time, we were unable to convert this energy into the usable form. That's why we are using the fossil fuel plants for many decades. But due to the shortage of the fuels and coal shortage that the world is facing right now, due to this, we are just moving forward and taking our discussion to the renewable energy resources. So, with the 1839, Alexander Becquerel, a French physicist, he had discovered the photovoltaic effect and setting the milestone for this power generation through solar. In 1883, Charles Fritz developed the first solar cell whose efficiency was less than 1%, but the it is a setting stone for this power generation. Later, with the innovation and the technologies and new upcoming semiconducting materials, and the composites are very energy efficient, and at the same time the cost is reduced and the size is also very small. Since the generation or operating cost of the solar power plant is very small as compared to our normal thermal power plant, which is we are running on daily basis, and its capital cost is too high as we are concerned about the solar power station. These are some champion modules which are at some at operational level, some are at laboratory research level. The research laboratory is National Renewable Energy Limited, US. This is available on their website. This is the MATLAB code for the irradiation and insolation that we are using. The graph which we are going to plot is between the irradiation versus wavelength and insolation versus wavelength. This data is available at NREL website. This is typically the historical data with the reference of which we are going to plot this characteristic. Mind well, this characteristic is with the reference of sun, not with the reference of earth. So we have not considered the locality here, the declination angle, etc. here is not considered. This is basically reference with the sun. So the plot is like this: solar irradiation spectrum and insolations versus the wavelength. This wavelength is from 0 to 4000 nanometer. The radiation is measured in the watt per meter square per nanometer, and insolation is measured in the kilowatt per meter square. The generation estimation, why it is required? Actually, we have developed an art to convert this solar energy to the usable form of electrical energy, and we are utilizing it. But as and when the introduction of solar energy is into the our conventional grid, it will create some nuisance. Means we have to justify that how much power is injecting into the grid, so the estimation is required. The estimation is essential in order to define the correctness of the operation of the protective device which we have inserted in the power grid network. and also to design the new philosophy of protective designs. The estimation study is also important as the reliability and security of the network is totally dependent on the protective devices operations. So in order to achieve the correctness of the operation, we need to estimate the generation through these renewable resources. Estimation is also important in order to carry out the actual power flow, because whenever this kind of generation is inserted at any level, whether it is at generating level or distribution level or it is at transmission level, this will cause the change in the power flow as well as its direction. So in order to design the feeder power flow direction, relaying philosophy with the current carrying capacity of the conductor, short circuit level of that feeder, etc. parameters which are typically electrical specifically. So in order to define this, we need to estimate the generation. That's why we have carried out our studies with the generation estimation. There are many such softwares available in the uh, present era like PVSys, PV Watts, Plant Predict, System Advisor Model, Helioscope, etc. But we have used PVSys due to some advantages, user friendliness, and its availability. Here we have considered the grid connected system design for small or micro scale power generation. Means our generation is limited with 25 kilowatt, which is less than 100 kilowatt. So the plant is small scale generation, or in terms of single phase plant we have considered 3.3 kilowatt, so it is a micro scale generation. These plants are at distribution network at load level, so they generally it is a rooftop solar plant. So both in the residential zone as well as in commercial zone. So the operation of such power plants are governed by IEEE 1547 standards, which were all the power plant of such kind they have to obey the standards defined. The growing importance of such power plants are due to several schemes or the benefits that the state government as well as the distribution companies are offering to the consumers at the distribution level. So they are attracted towards this kind of renewable generation, and we are getting at it at a near load center. So the transmission and distribution losses which are occurring presently from the source to load is minimized. This is the front screen of the PVC software. We have used PVC 7.2. In this, the project design step, you can see this. There are different types of modes available: grid connected, standalone, and pumping exercises. The utilities are, we have databases like metronome data, NASA data for the locality, and etc. Several tools are available. The measured data can be recorded and can be used as and when required. The tutorials are also available on the website. You can start your estimation at any desired location with the help of these video tutorials. They are very user friendly. This is the basic setting that we have undergone for our location. We have used the fixed tilted plan, means the rooftop solar is fixed at one location irrespective of the sun path. We are not changing its orientation, we are fixing it to at some level, and the tilt angle is 25 degree, for which we are getting optimal irradiation yield. See, this loss is 0.0%. This figure is generally taken care for the setting of the tilt angle. Azimuth angle we have taken at 0 degree, but you can vary as per your requirement. This is the system configuration for case 1, that is 3.3 kilowatt power. Here the area available is 18 meter square and total needful modules are 10. We have taken our Adani solar module that we have already specified, and This module is actually not available, so we have generated the pen file for this module and updated in the PVC software. Everything is available over here. The temperature ranges, etc., we have already set as per the geographical location availability. The inverter we have used for the same company, that is Mindra, and it is also not available, so we have updated the .ond file for the same. We have 5 modules in series and such 2 strings are connected, so total number of modules are 10. The size required is 20 meter square. Now here this is 18 meter square is the active area, but for the cleaning purposes, for the accessibility, for maintenance, etc., we are keeping some distance which is something, so that will be added into this and it is 20 meter square. So now you can see this, the design is perfect. So this kind of parameters we have to see and we have to check for the simulation. Once it is done, you can go through the simulation tab. This is for case 2 setting. Here we have used Topson module and INVT solar technologies inverter module for this. This is 3-phase connection and it is for 25.2 kilowatt power. The area is 156 meter square and module required are 80. Now, actually, before starting this, we have to calculate the load demand of this, which is not a part of this paper, but it's an exercise that we have carried out by checking the few historical load demand of a period, which from the electricity bill that we were getting from the distribution company, and this historical data has helped us to find out the average demand of the load, and from that we have calculated the module required, the capacity of plant at that location that we have carried out already. This is actually the loss diagram, which will be helpful to identify at every stages what should be the output. This is 1834 in case 1. This 1834 kilowatt hour per meter square means the energy irradiation is this 1834. Out of this, the amount available with this IAM factor and everything, this is 1911 kilowatt hour per meter square. This value is per meter, so we are multiplying with the total area 20 meter square and we are getting it nearly this, because the efficiency is 16.42%, so we have to multiply it with 0.1642 and the output is this. This is the available of energy 6333 kilowatt hour means 6333 units available at nominal energy at standard temperature conditions. So these condition are changing and we are not getting it because the irradiation changes uh, at every day, every time, so the output also changes. The final output, the amount of energy injected into grid is 4850 kilowatt hour. This is, mind well, this is the energy injected. You can find out the amount of total power injected divided by 24 hours or divided by mean sun path means 12 hours. You can find out the total amount of power injected at the location in both the cases like this. So it is 47.13 megawatt hour means 47130 units of energy divided by 24 hours time, we are getting the amount of power to be injected in the network. So this is how we have estimated the total amount of power at that location only. This is the location specific, as we have already fed some basic settings in the PVSys module. So after simulation we are getting these results. This is the general diagram for the grid connected system. We have here this our solar modules. This is IGBT controller or inverter actually. This is inverter inductance of inverter side, this is grid side inductance, and this is the value of capacitor for coupling. Transformer and grid network, that we all know. This is the basic setup diagram. We have here used MPPT controller, and MPPT's programming is of P and O, means perturb and observe type, means hill climbing algorithm, that we all know. The everything, every minute detail, parameter settings and everything are already explained in the paper very well. So for this you can refer our paper. These are the waveforms that we are getting: the voltage waveform and the current waveform. Voltage waveform is nearly sinusoidal, but current waveform is distorted. The practical implementation of this inverter is not part of our study, and design of the inverter is not considered. We have just configured inverter for our specific estimation. We have not undergone for any setting or design of inverter specifically. We have used the parameters available in the data sheet of the inverter that is installed at our premises. Now we are changing our focus from this estimation to the issues with this penetration. First of all is the availability. As we are all knowing that sun is available for 12 hours a day, and due to some climatic conditions, some tropical condition and geographical location, the availability of sun is not that much in some continents. So the availability is the major issue. The integration with the grid is effective if the available solar power is capable of load sharing throughout the period of the operation and continuous, like our synchronous generators and fossil fuel plants. During its non-availability, the active network of the day time works as a passive network and disturbs the operation of the healthy network. The storage is one of the major issue as concerned with the availability. We are using the surplus power in the form of pump hydro storage, but again the locality, the land cost, the construction of this hydropower storage, and also the efficiency during its conversion. Also, second option is flywheel storage, but the size of the flywheel, the amount of storage capacity, etc., is also somewhat typical. So we cannot store the huge amount of power with this flywheel storage. One of the promising solution is the battery storage, like lithium ion or lithium polymer batteries nowadays. But the size of the storage again, and the cost of the batteries, and most importantly its recyclability, because if we recycle it we can use it again. So this is also a challenging one. Liquid hydrogen storage is also an option, but developing nations are not able to afford it because it is the cost is the issue, and also some safety issues, and this is the emerging trend, so some innovative research is needed. The new thing available is heating, ventilation, air conditioning system, HVAC system, but the cost of the storage and its application is limited because it will apply only where we are using the ventilated air condition, means we are utilizing the amount of surplus power in the form of some thermal storage, and we are passing these cold water or cold wave or some conditioned air through pipes throughout the building, so we can save some amount of energy consumption. Like we are using centralized AC system and all this, we can use this HVAC system over there. Major issue is the power quality issue that we have already seen. See the wave shape of this. The wave shape is not sinusoidal. The current wave shape means it is a combination of fundamental as well as the multiple of this fundamental, which we are talking like that it is the harmonic component. So the power quality issues with the generated solar power plant is highly predominant in this case. As the power produced by this solar is dependent on irradiation, the main control parameter is the duty cycle of the inverter that we are using to keep its operation to near maximum power point tracking. So MPPT point. With the grid connected application, they require an inverter and a filtering circuit to make this power quality should be as sinusoidal or as smooth as our normal AC sinusoidal supply available. Filter circuit is used to minimize the ripple content and removes harmonic contents, and output is near about pure sinusoidal, or you can say the harmonic free. So we can, after this kind of activity, we can inject this power into the grid. The major concern here is the protection system, because as and when we are installing the solar at distribution level, the previously passive network from where the power is flowing in one direction from source to load is now converted in bidirectional mode. So the relays are function, or they are set for the operation in one direction only. In this case, we are not getting the reliable operation even if the fault occurred in the range of that relay. So we need to change the relay settings according to it, but this power is not available throughout a day, so we have to change the adaptivity of the relay. So more preferably is the directional relay which we are going to use is to be digital type, so we can adapt or modify the settings as and when required, and at the same time we can incorporate more than one feature in the same relaying unit. Also, there are several issues like underreaching of the relay, the coordination problem, system stability issues, power system flexibility issues with voltage rise and voltage sag and swell issues, unbalanced at point of common coupling. There are several many more issues, but with the limitation of time, with the limitation of the paper length, we have not concerned this into this study. This is the future scope of our ongoing research. The conclusion part is very predominant because we have estimated our generation at this point. The new measure of any country's progress would be how effectively they are now going to use this renewable energy available for their daily load demand. The estimated energy in both the cases are respectively 4850 kilowatt hour per year and 47.13 megawatt hour per year. This is the actual generation estimation at this location only. Such number amount of power is injected in a year, but there are several power plants working in together and they are installed at the distribution level, so the amount of generation they are injecting into the grid is now a serious case to be taken care of. Otherwise, the protective system, the conventional grid system, all are going to face several issues with power system protection as well as power system operation. Inverter configuration is accordingly updated as per our requirement and as per our plant installed at location. The major concern is the improvement of the protection system operationality. As the amount of infeed changes, the location changes, the relay settings are need to be updated on the daily basis as and when the generation increases or decreases at certain location. The issues discussed can be solved using software tool as well as with manual calculation for the verification of the results that we will be getting with the some studies in future. Also, we can go for the estimation of this generation with all the parameter changes, like we can change the tilt angle, we can change the locality, we can change the basic temperature differences and etc. We can change the horizon etc. There are several parameters that we can modify for our future studies and one can learn from this. These are some references for my studies. Thank you. If any question and answer are left, I'll be happy to answer it.